Okay, again, these are a lot like the previous problems, but the deal with these has got a little more going on. For example, that natural logarithm is being multiplied by 2, but remember, we have a property of logarithms that says if I have a log of any base with some number with some exponent, I can rewrite that exponent as a multiplier. I'm just going to use that property the other direction to rewrite that logarithm as ln of x squared. Because I cannot apply an exponent through that number 2. I had to do something with it, or I was pretty much stuck. Now I can apply base e to both sides. And that cancels on both sides, and I'm left with a quadratic. X squared equals negative x plus 12. Now I'm going to solve the quadratic by getting a 0 on one side. And I get x squared plus x minus 12 equals 0. X plus 4, x minus 3 equals 0. And I get two possible solutions. X equals negative 4 and positive 3. And when I look back, if I put a negative 4 into that first logarithm, I'm going to get it's going to give me doesn't exist outside a domain area. Sometimes, and the reason I'm looking back at the original is sometimes the math that happens inside the logarithm will make it positive. If you look at the logarithm on the right-hand side, then if I put in a negative 4 and add 12 to it, I'm going to get 16. And even if I put in a positive 3 and add 12 to it, I'm going to get a 9. So both solutions work on the right-hand side. All right, let's take a look at D. So again, I'm going to change this multiplier into an exponent. And I also have subtraction here with the other log. So I'm going to skip a step and just write it as a quotient, a fraction. Okay, and on the other side, I've got a little bit of a problem, but it turns out it works out. So I can't get that 2 to be inside a log anywhere. There's no rule that allows me to do that. So at this point, I do have to, right in my base I forgot, I do have to apply an exponent base 2. It's the only thing I can do. So that exponent base 2 is going to be applied on the left-hand side. To the right-hand side, it cancels. I just get x squared over x minus 3. Now what happens on the left-hand side is we have this little property of exponents that says if I have the same base with different exponents and they're multiplied together, then I can add those exponents and just have a single base. Now if you look, I actually have addition in the exponent base 2. So what I'm going to do is I'm going to simplify that by making it the multiplication. I'm going to use this property backwards. So here's what I do. I get 2 squared times 2, and in the exponent I'll get log base 2 of 3. Okay, that works out pretty nicely because the base 2 and the log base 2, base 2 exponent, log base 2, they cancel. So I am left with x squared over x minus 3 is equal to 4 times 3. So my 2 squared turned into 4, and now I have a 12 on the right-hand side. So I'm going to multiply both sides by the denominator, x minus 3. And I get x squared equals 12 times x, which is 12x, and 12 times negative 3, which is negative 36. Again, I'm going to get both those terms on the other side and factor it for my solutions. And this factors to x minus 6 times x minus 6. So I just get one solution out of this, x equals 6. Now I think the problems on the quiz that are like this will have 2 solutions. This is just the best I could do to make up a problem like that. Okay, stopping this example. I'll see you on the next one. This